Welcome to this video lecture on the subject of sample size and power. In this lecture, we're going to talk about what we mean by a significant difference and how we go about finding it. Let's talk first about what we mean by the phrase a significant difference. In everyday life, when someone uses the phrase a significant difference, they mean a difference that's big enough to be important. Suppose bags of peanuts are meant to weigh 25 grams, and suppose they don't. Suppose they weigh a little bit less. Let's say that the average weight of the bags is 2 grams less than what's stated on the label. Is that significant? Well, that's a question for the customer, or for an expert in nutrition acting on behalf of the customer. A significant difference means a difference that's big enough to be important, and that's how the term is usually understood, and that's a useful way to use those words. Now, in statistics, we use the word significant in a different way. When in statistics we talk about a significant difference, we mean we have data to prove that a difference really exists. We mean that we are sure there is a difference. We are not making a judgment about whether the difference is big enough to be important, because that's not the role of a statistician. What does a statistician know about peanuts and nutrition? Very little. Okay, so in statistics, we use the phrase a significant difference to say we can prove using the data that a difference exists. Now, the difference may be big enough to be important to somebody or may not. So we need to bring these two ideas together. We don't want to waste our time in statistics identifying differences that are so small that nobody cares. But when there is a difference that's important from some practical point of view, we want to be able to identify that the difference is present and that it's big enough to be important. So we deal with this by choosing a sample size that's big enough to find a difference that's big enough to be important. So, how do we choose a sample size? A very large sample size, as I said, may detect differences that are so small that they're trivial, and a very small sample size might miss differences altogether and not notice differences that are there and that may be important. So the question arises, how big a sample do we need when we're carrying out a statistical test, when we're looking for a difference? This question is a bit like another question that I will use as an analogy. Suppose you're looking for a needle in a haystack. How much time do you need to allow for that task? Well, that depends on three things. It depends on how small is the needle. A smaller needle will require more time. It depends on how big is the haystack. A bigger haystack will require more time. And thirdly, it depends on how badly do you want to find that needle. If you want a better chance of finding the needle, that requires more time. Now, this little story I've told about a needle in a haystack is very like what we do in statistics when we're looking for a difference. In statistics, we're not looking for a needle in a haystack, we're looking for a difference. Suppose the label says the mean contents of these bags is 25 grams, and we're carrying out a test to see, is that true or is there a difference? So in statistics, we're looking for a difference. We're looking for a difference between the hypothesized value of some parameter, like the mean, and its actual value. So we're looking for a difference, and we often call this delta, which is the Greek letter D, or else we just use the word difference. So the first thing that the sample size depends on is how big of a difference would be important to us. And we ask the customer or the subject expert to tell us how big of a difference matters to them. It's not a statistical question. It's a question for the client. In the needle and the haystack story, the second issue was a bigger haystack hides the needle. In statistics, random variation hides the difference. The bigger the standard deviation, the bigger the sample size we will need, because it's more difficult to observe a difference when there's random variation present. So this second quantity is called sigma. So delta is the first issue, sigma, the standard deviation, is the second issue. And we can find that out from the data. the data will tell us the standard deviation. If we have data on that process from previous history or from a current sample, this will give us an indication of the standard deviation of the process. And the third issue in sample size is, well, it's like, how badly do you want to find that needle? Well, how badly do you want to find out if there's a difference? What chance do you want? What probability do you want to have of finding a difference of size delta if a difference of size delta exists? And that's called the power of the test. The statistical power of a test is the probability that, having done the test, you will reject the null hypothesis. That is, it is the probability that you will find a difference if the difference of size delta is present. So the three issues in deciding a sample size in statistics are delta, sigma, and power. How big is the difference? How big is the standard deviation? And what do you want to be the probability of finding the difference if it exists? The first question, delta, is a question for the client. The second question, sigma, is a question for the data. And the third question, power, is a question for the statistician. Typically, in statistics, we like to have a power of 80%. This gives us a good chance of finding a difference if the difference is of size delta. If the difference is smaller than delta, we have a lesser chance of finding the difference, but that's okay because we don't want to be bothered with finding a difference that's smaller. And if the difference is bigger than delta, then we have an even better than 80% chance of finding the difference. There is one other clever thing that we can do in power calculations. A power of 80% gives us an 80% chance of finding a difference. And I call this research. When we're looking for a difference, I just like to use the word research to describe that activity. I know it's a bigger word. But sometimes we're not so much doing research as validation. We're not looking for a difference. We are seeking to prove that no difference exists. If we're doing validation, we can choose a power of 95%. This gives us a 95% chance of finding a difference if a difference of size delta exists. And if we choose a sample size that has a power of 95% and still cannot find a difference, then we're in a position to assert that there is no difference. It's like we've put the onus of proof on the defense instead of on the prosecution. We have taken that familiar 5% boot and put it on the other foot. 95% power we use for validation. When we have the values of delta, sigma, and power, we supply these values to a piece of software, which then calculates the sample size and tells us the sample size that we require. And typically, if we're comparing two populations, it will tell us the sample size we need from each. Sometimes we carry out a statistical test without calculating the power in advance. And if we do that, it's worthwhile calculating the power afterwards, especially if you accept a null hypothesis. If you reject a null hypothesis, you really have no worries because you went looking for a needle in a haystack and you found the needle. So you don't have to ask yourself, did I spend long enough looking for the needle? Of course you did. You've got the needle. It's there in your hand. But if you accept a null hypothesis, it means you didn't find a difference. But maybe there is a difference and you didn't find it. So in that situation, when a null hypothesis is accepted, it's important to calculate the power, even retrospectively, and see, was the test powerful enough? Because if the power was about 50%, like an indifferent power, you might say, I didn't find it, but I might not have found it because my sample wasn't big enough. Whereas if you have a 80% power or thereabouts, and you didn't find a difference, at least you know you had a good chance of finding the difference. So there probably isn't a difference there. So you can calculate the power afterwards, see how powerful your test was. Although the ideal way to do life is, in advance of the test, calculate the sample size that's required, and then you know that you're in a good position to find the difference if the difference is present. You can read more about this in the textbook in Chapter 5, Sample Size and Power.